All right, in this video, we're starting a new unit. As always, excited, all right, to start a new unit. And this unit, we're going to talk about quadrilaterals, all right? And we know that quadrilaterals are figures or polygons with four sides. And we should also know that the sum of interior angles of a quadrilateral equal 360 degrees. But there are a bunch of quadrilaterals that we're going to talk about in this unit, and I'm really excited to talk about each one. So what I want you to do in the first couple of pages, just become familiar with some of these quadrilaterals that are from your past, all right? And there are different features, all right? One is the kite, the trapezoid. We're going to talk about that in a little bit. Isosceles trapezoid. You go to the next page, talk about the parallelogram. Please take a look at these. Don't just brush through them, even though we will talk about them in later lessons. The rectangle and the rhombus and square. All right, but in today's video, what I want to focus in on is the trapezoid. So the trapezoid is a quadrilateral with at least one pair of parallel sides. So what I want you to do, which I think is important, is let's highlight that. All right, with at least one pair of parallel sides. The parallel sides are called bases, and the non-parallel sides are called legs. So if we look at our figure here, our legs are our non-parallel sides, and our bases are the parallel sides. And we also see our symbol there, which is important, which means parallel. Okay, so let's go down. It says the median. The median, sometimes called the midsegment of a trapezoid, is parallel to the bases. That's important, parallel to the bases, and has equal length to half the sum of the length of the bases. All right, so this median here, once again, the highlighter. All right, so MN is our median. Very important. MN is our median, and I don't like that color because it didn't really come out. Here we go. MN is the median, and MN is equal to 1/2 DC, because DC is a base, plus AB. All right, so what's another way of writing that if you like it? This way you can use it. You can say that MN equals DC plus AB divided by 2. All right, you absolutely can use that. All right, now let's move down. An isosceles trapezoid is a trapezoid with congruent base angles. All right, now some properties of an isosceles trapezoid are that the legs are congruent. All right, the legs are congruent, and also the diagonals are congruent. And we're going to talk a little bit more about that in class, especially after we do our proof, I just heard you, in a little bit. All right, now, so let's look at example number 1. So example number 1 says, find the measure of each angle in trapezoid ABCD. All right, so we have to find the angle measurement, the missing angle measurements, that is, because we know that angle A is 78. Now, there are a couple other things we know. We know that AB is parallel to DC. That's important. Why is it important? Because we know that AD now becomes a what? Yes, I heard you. A transversal. All right, that's correct, a transversal. So, my transversal, I know that the same side angles are supplementary. Okay, that's important. Okay, same side angles of a transversal, the angles are supplementary, that relationship. So I know that if angle A is 78, then angle D must be 102. And if angle C is 132, then angle B must be 48. Because those two angles also are supplementary. Okay, now there's a check. What is it? Add them up. We just said that in a quadrilateral, the four angles added together equal 360 degrees. Okay, now, so I would write that down. Let's do that. Consecutive angles. Are supplementary. Okay, let's move down. It says given trapezoid star with mid-segment MN, sorry about that, find X. So we know that MN is 19. We know that ST, a base side, is 4x minus 7. And RA, another base side, is 6x plus 5. So we know that we're going to have to set up an equation. We're looking for X. So let's start with MN. MN equals 1/2 ST plus RA. All right. Now, we know MN is 19. That's given to us. 1/2, we bring that down. And then we also know that ST is 4x minus 7. And that's going to be plus RA, which is 6x plus 5. Okay, now I'm going to work inside the parentheses. I like to do that. I think that's important. So I'm going to have 19 equals 1/2. All right, I'm going to combine my like terms. I'm going to get 10x minus 2. I think everybody's good with that. Now I'm going to distribute my 1/2. And I'm going to have 19 equals 5x minus 1. Okay, I'm going to add 1 to both sides. I'm going to get 5x. I'm just going to move over here. Equals 20. Divide both sides by 5. And x equals 4. And that's my answer. All right. Let's go to the next page. All right. So on the next page, what we want to do is we want to prove a quadrilateral is a trapezoid. Okay. And please relax, breathe. It's a coordinate proof. All right. And I think we like the coordinate proofs. Actually, I know we like the coordinate proofs. But anyway, so it says to prove that a quadrilateral is a trapezoid, we must show that it has one pair of parallel sides. Okay, so I'm going to circle that because that's a big one. One pair of parallel sides. Well, on the coordinate plane, we should be thinking, all right, when we think of parallel sides, immediately we're thinking of same, and I know I can hear from you, slopes. Okay, same slopes. So we like that. Rise over run. All right, delta y over delta x. All that stuff you've been doing for many years. Okay, it says to prove that a trapezoid is isosceles, we must use one of the following reasons. One of the following. You don't have to do both, but one of the following. A trapezoid with congruent base angles is isosceles. That's going to be a little difficult on the coordinate plane. All right, and then number 2, a trapezoid with congruent diagonals is isosceles. Now that one sets up better for us. So let's attack this. It says given quadrilateral ABCD, A is 1, -4, B is 10, -4, C is 9, 2, D is 2, 2. It says prove quadrilateral ABCD is an isosceles trapezoid. So what I'm going to do, and I don't want you to sit around and wait for me because I want you to do the same thing. Obviously, let's plot this trapezoid. So I'm going to do that right now. All right, so I have my trapezoid plotted nicely on the coordinate plane. All right, and now let's go at it. So the first thing I'm going to do is all right, I have 2 different approaches. My first approach is to prove that I have 2 lines with the same slope. So I have one pair of parallel sides. So I'm going to look immediately at the slope of M, slope of DC. That's line segment DC. And I mean, I can use the grid. it's pretty clear that the rise for DC for that line is 0. All right, now if you don't believe that, you can put in your points, you can put in your slope formula. All right, and the run, you can pick any point you want. All right, but let's say it's 5. Well, that slope is going to be 0. And then the slope of AB, M, line segment AB, well, that's the same case. Well, that rise is 0. All right, and I can run anywhere I want there. All right, because the slope is a constant on the line. That's 0. So what I can say from here is that AB is parallel to CD. And the reason is they have the same slope. All right, oops, sorry about that. Okay, they have the same slope. All right, now what we need to do is we need to take a look at our, all right, like I said, the angles are very difficult to take a look at and prove on the coordinate plane. So let's take a look at those diagonals. So if I draw diagonals, let's see, let's get some straight ones, because I know some people that love straight lines in my class. So I have diagonal AC from one vertice to the other, and then I have diagonal DB. So if I can prove that those two lines are congruent, then I can say that I have an isosceles trapezoid, because I've already proved that I have a trapezoid. All right, so how am I going to do that? Well, I want to know if the two lines are the same length or the same distance. You got it, distance formula. So let's write that down. So I know my distance formula equals the square root. Oops, I went through my 5, that's okay. All right, parentheses, x sub 2 minus x sub 1 squared plus parentheses y sub 2 minus y sub 1, and that's squared. Okay, so I'm looking for AC and DB. So AC. And I have my points here, so I'm just going to plug them in. And you can do the same. And also, please use your calculator. So I have 9 minus 1, and that's going to be squared, plus 2 minus negative 4 squared. All right, I plug that all in my calculator, and it gives me that AC is 10. All right, now I need to do the same for DB, line DB. I should have used a different color, sorry. I know people like the different colors. So I'm going to have 2 minus 10 squared, and that's going to be plus 2 minus negative 4 squared. I plug that all in, and I get dB, or line dB, equals 10. Okay? Now I can make a statement, all right, because I have that my diagonals are congruent. So I can say that AB, let's use a different color. I can say that AB CD is a trapezoid. Due to having one pair of parallel sides, and I also can say AB CD is isosceles. Due to DA is congruent, line DA, which is diagonal, is congruent to line CB. Please, as I've said to you many times this year, please make sure when you do all your work, you have your concluding statement. That's very important on these proofs, especially as we get closer to June. All right, now, many key ideas. That's why there's a nice big box for you. So fill that in, and I will see you tomorrow. Remember, yes, go Cats, go Knights.